So here we've got a Linn Karik CD player, and I normally don't deal with CD players because their problems tend to be mechanical or laser or software related, and you know, you just can't guarantee any sort of ongoing success, so I just kind of avoid them. But this one, the owner was local, so he was able to drop it off, which is great. And he said that the unit plays, but after a short time the circuit breakers in the house trip, and so we're expecting some sort of earth leakage problem going on here. So I've not powered this unit up yet, but what I do have is I've got it plugged into a socket here, an extension socket, and I can break the earth path there, and that's what we're looking at on this meter on the right hand side. So we're looking at the earth leakage current on that meter. And when I plug the unit in, so that's it plugged into the mains, and it's not switched on at the mains yet, but we can see there that we've got about 1 milliamp of leakage, and that should be 0. We can see actually that that's rising there. And if I go and switch the unit on at the mains, so it's still not switched on here, but we're up to sort of 2.5 milliamps and rising. And I suspect if we leave that long enough, it might cause a trip at that. Anyway, let's switch the unit on and we'll see what happens there. So the earth leakage, the circuit breaker will go at 20 milliamps. So let's see what happens when we power up. So in actual fact, that's actually powering it up hasn't made very much difference at all, which is interesting. Let's power off again. So it drops a little bit, but not overly much. So what I found is that the current sort of steadily rose to about 3.5 milliamps there, and then the circuit breakers here, they tripped. So my expectation is the current went up to 3.5, and then just things started to conduct heavily, and that's what tripped the breaker. So what's going on here? You know, before we take the covers off, what are we thinking is happening here? And in a previous video we looked at XY capacitors and how they can be, well, what they do and how they can be problematic as well. And so we're suspecting this is what's going to be going on here. We're going to have the mains coming in, and this is going to be our live and neutral, and we're going to have some class Y capacitors here that connect the live and neutral to earth, and then our class X just goes across the line. So these are working as filters. So we've got a common mode filter here and a differential mode filter here, and that's their job. And what we're suspecting is that one of these or both of these Y capacitors are going to have become leaky, and that's what's causing the trip there. We're getting current from the live flowing through one of these capacitors and going to earth, which is what trips the breaker. So let's take the covers off and we'll see what we've got going on inside this unit then. Alright, here we are inside, and we can see we've got a switching supply here. This is what Linn call their brilliant supply, U25W. So we've seen that. This is common in some other units as well, so not a surprise there. So this guy is probably going to have some filtering on the board in there, but we can see actually we've got some Y capacitors here just soldered on the back of the mains inlet. So these could be our problem, or indeed there could be other capacitors inside this switching module here that's causing us a problem. So we'll take this out, we'll disconnect it, and then we'll see what effect, you know, what leakage current we get just by plugging into the mains inlet there, and see what happens, and go from there. Alright, so we've removed our switching supply here, and so there's nothing connected then from the input mains there. It's just goes to the cables, and we've obviously got these two Y capacitors here. So we're monitoring the leakage current again. Let's just plug in, and so we're seeing about 0.5 milliamp there. And if we turn the mains on, 2 milliamps right away and rising. and I'm not going to leave that on too long because it shuts down the power. So fairly confident then that these guys are the culprit, and you know, we might also find something inside the module here, but for now that seems to be fairly conclusive that these two caps here are the problem. So I think the next thing is we'll just snip them off and see what current we get then, and we should obviously have 0, so let's see what happens there. Alright, so snip these capacitors off, and leakage went to 0 as we expect. And then you know, we should be able to measure the leakage on them, and I've got a 50 volt rail here, 50 volts DC, and we can see that that capacitor there takes a wee while to settle down, but it's sub microamps, quarter microamp there, and dropping lower. And then if we look at the other guy, it's you know, 4 microamps there, so it's like 8 times higher, and that's only with 50 volts. So as the voltage goes up, things are going to get worse quite dramatically. So I think that's this is our culprit here. So we'll replace them, and we'll go ahead and open up this brilliant supply and see what we find in there. Okay, so let's have a look at this brilliant supply, and I've seen these before, and they've got these little plastic rivet things here that are holding them together, and I think with age they just kind of go brittle, and I've found that basically, you know, the only way to get them off is to cut them off, and then I tap the metalwork here and just put an M3 screw in. That seems to work quite well, but I've never had any success in retaining these things, so we'll just chop them off here. Save a lot of frustration just by doing this. There we are. And we should be able to unclip this now. There we go. So there's our brilliant supply as we've seen before. Let's see if we can get that out the metalwork here. Seen a little bit of moisture in there, you can see some rust. So here we are, and we've looked at these before, so there's not much point in spending too much time on this. But our mains is coming in here, and then we've got some common mode chokes here. And then this is the X capacitor here that's going to be across the line. X2 it says there, yeah. So that's right. That's what we expect. So this seems, you know, obviously looks in reasonable shape, but we know that these 6 capacitors here, they're going to be dry, so they want replaced. And we'll just whip them out. We'll maybe measure them, but we'll take them out and see where we go. These bigger ones are usually alright, so we'll leave them for now. So let's go, let's get these out, see where we go. Alright, so we've got these caps removed from the supply, and they don't measure too badly actually, but you know, it's kind of false economy not to be changing them when you're in this deep anyway, so we'll get these done. And then there's a whole bunch of low-level electrolytics on this board here. These are all the same age, they've had the same work, so we really expect these to be in poor shape. So we'll go and replace all of these. Right, so we need to get this main board out now to replace all these caps. And what I'm finding is that we've got these toroid cores here, filter cores, and they are restricting me getting the board out. So it means we've got to remove the whole transport, which is a bit of a nuisance. But anyway, I've undone that now, so this can just lift out. I'll put that to the side, and then we should be able to get this board that's free now. Right, so we'll get that on its own, get all these caps off, get them replaced. Right, so that's this board fully recapped now, and again they weren't overly bad. This was the worst one here. ESR just maybe 2.5, approaching 3 there. So not a disaster, but still, as I say, it doesn't make sense to be in this deep and not to deal with that stuff. So that board's been recapped, the power supply's been recapped, and the next thing we'll just go and tap out these holes so that we can get some screws in there to put this switching supply back together, and then we can start to look at putting the whole thing together. Alright, so we've got a bunch of new capacitors delivered here, and I'm just going to do the 50 volt leakage test that we did before. That's 50 volts DC. This capacitor read somewhere between sort of 4 and 8 microamps leakage before. It's a little bit lower today. It's obviously been sitting idle for a wee while. But when we measure the replacement, it shows absolutely nothing. So that's good. And so we'll just go and get a couple of these installed now and see where we are there. Alright, so we've got our new capacitors installed here, and we're plugged in and switched on, and we're measuring the earth leakage here again in this meter. And I'm on the microamp range here. Previously we were measuring milliamps, and it was going north. Here we are measuring microamps, and we're just under 2 microamps there, so next to nothing. Quite happy with that, and I think the next step here we'll get our brilliant supply installed, and we should be playing music then. So let's get this installed. Right then, so we've got our supply installed here, and the CD player's obviously running here. You can see the disc rotating there, and we've been through a few songs. We're up to track 5 here, and still sitting about 2.5 microamps there, just bobbing around that. So it's about 1,000 times less than where we started when we had the problem parts in there. So all looking very good. I think the next thing now, we'll get the covers on and just do a kind of lengthy listening test, and we'll monitor this current for a while as well, see how we go. But yeah, next thing, get the covers on. Alright, we're all back together then, and I've been playing this for a while. It's a really sweet sounding player. This actually beats a lot of modern players in some respects. Been monitoring the current as well, absolutely stable there, no problems, so that's all fine. I've got some other stuff here. This is a pre-XP and an 8 power that belonged to another customer, so these have been repaired here as well. So we're ready just to have a wee listen here and see how we go.
1, 2